Well, we are currently in the middle of a war, ongoing war. It's not the traditional one with a bunch of soldiers running around and shooting at each other. It's cyber. Everything is slowly online. Countries are attacking each other constantly. It's kind of a cheap way of fighting a war because on one hand they can do a lot of damage. Just look at Russia recently trying to attack the US energy nets. And at the same time, they're standing and smiling, looking happy and innocent and saying, hey, we are not doing anything. We are just nice guys. Trust us. Well, it's a little bit hard to trust countries who are acting like that. But that's just the totalitarian regimes. We also have the other countries we consider more lawful. And they also are fighting these wars. And for their purpose, they are also using a lot of legal information. So we have the United States. They are the good guys, according to themselves. And they have a ton of laws added. We have the FISA, which is fairly infamous. Basically just says we just want to read data from everybody else because everybody else is potentially doing something bad against us. When there was 9/11, after 9/11, they found another one, the Patriot Act. And now, this year, they just completed the Cloud Act, which seems to be the most bad of them all because it just says, we don't give a... Your data is ours, period. So, what happens? Well, in 2000, EU and US tried to put together something. They had this thing called a safe harbor. Cool. We trust each other. Then something happened in 2013. Dude called Snowden here came to the scene, and we've suddenly find out that it was not the case. So 2015, European Court of Justice simply just threw away the entire thing saying, nope, not allowed anymore. Panic, politicians in panic, they quickly tried to hash something together called the Privacy Shield, and it was basically more the same thing. But at least now, in a couple of weeks, the General Data Protection Regulation, GDPR, is going to go live. It has had an incubation time of, I think, roughly 18 months or so for companies to adjust to it. And let's see. Now we're going to have US on one hand saying all your data is ours, and US on one hand saying all your data is ours, and EU on the other saying we want to protect the data. We want to protect citizens. That's going to be a funny battle. So buy popcorns and beers and watch on the sideline. Some of the biggest cloud providers we have in the world is Microsoft. We have Amazon. We have IBM. This little box here is from ZDNet from February, where they're kind of listing the biggest when it comes to money. And also a lot of big companies up there you might recognize. There's also Alibaba, but that's Chinese, and you can... Yeah. So, what they're usually offering in a cloud system is a bunch of different AAS things. Everything is as a service. And what we can do, we can go into those two types, which is called IaaS, Infrastructure as a Service, or PaaS, Platform as a Service. In those two, we can actually add software. We can't add any hardware, but we can add software. So, as I mentioned, Snowden, he was telling us all about what NSA, GCHQ were doing. And back then it reminded me a little bit about an old document I read many years ago when I was slightly younger, by Ken Thompson, one of the guys who was helping building Unix. He got a Turing Award, and he wrote a little paper, about 3 pages, Reflections on Trusting Trust, where he basically went through some of the simple idea that you want to build some software and you want to add a little bit of something nasty to it. So what do? You build a C compiler. You take the C compiler, you have the source code, you add something that tells that this C compiler, whenever it's compiling anything, adds a nasty thing to the bottom or in the end of it. So it's always there. Then you remove this piece of code from the source code and you publish the source code and see, here's a compiler, here's a source code. Source code look all perfectly wonderful, nothing there to see, but when you compile it, anything you compile with it always got this little block in the appended that just does something nasty, whatever it is. So trusting trust, we already heard that before with trust. It's an important thing, and the question is, how far down the rabbit hole can we go? So, as already mentioned, most of the clouds are American. Forget Alibaba, but Alibaba is Chinese, and I don't know how many people trust the Chinese will be doing anything, well, nothing bad with our data, but let's see. Microsoft is actually, this is why I find it fantastic being in this building today. Microsoft has been one of the few companies who actually stood up and did something. So, go Microsoft. 20 years ago I wouldn't have said that, but today, go Microsoft. I'm really curious about this result from Supreme Court in the United States, which is coming here in June. Talking about what to do about data stored in a cloud, or, well, basically just on servers in Ireland, which the United States would like to get their hands on. It's going to be interesting. So what can we actually do? Well, as I started mentioning, we have IaaS and PaaS as the two potential cloud systems we can work with, because we run our own software. We can't use our own hardware unless we also go into an actual hosting company. But if we just focus on clouds, not possible. Encryption is everybody's solution for everything. But encryption is just a technology, and a technology used wrong can go wrong. You have to put it in right. So you need to ask yourself some questions. Where you want to add cryptography? Which layers? How about managing the keys? So without further ado, let's introduce the thing I started working on 18 months ago. Cryptographic Web Store, or CWS. Focus should be purely on data collaboration. A secure way for people to exchange data which is stored in a cloud or on a hosting provider somewhere. So instead of focusing on, we want to know a lot of things, I'm just trying to narrow it down to one little thing: bytes. Don't care about anything else but bytes. Something comes in, we encrypt it, we store it, someone else can decrypt it if they allow, and they can get it back. We do not care about what's in it. That's not the main target of this system. The system should also be something you can integrate into existing applications, into mobile apps. You should be able to just take it, it's open source. So you can just take it, download it, and just build your own system around it. Or directly embed it if you like. But main point is simple API, public API, and make sure that it's something that is completely versatile. So you can do all aspects you need to. And of course, open source. You have to put your trust somewhere, and open source is at least a basis. And since I'm not the one building this system and giving it to you unless you ask me to, you can trust me. Well, at least I hope. So, one of the core concepts is this thing I'm calling circles of trust. When you want multiple people to exchange information together, you want them to be able to control who can access, who may write something, who can add people to this trusting circle. And you also want to be able to remove them again, because if you're looking at a company, you have someone started working for you, they become a trustee, they leave, you're removing them, they are no longer a trustee. So this brings a couple of interesting questions regarding how to manage the keys. actual core part of the information which the system is supposed to hold dear and near. This is where I'm using the same techniques as in Pretty Good Privacy, GNU Privacy Guard, meaning every person has an asymmetric key consisting of a public and a private key. I'm storing the private key encrypted, just to be sure. And every circle of trust has its own symmetric key. So each trustee has a copy of the symmetric key, which is encrypted using the public key. And when they want to access it, they have the private key, whereby they can open it and extract all the information which is inside the circle, or add data, or do whatever they have to. So I did put a little bit of focus on server side, because if you want to make sure you can remove a person from a system, you also have to think, how can we make sure it's really done properly? And if they have the key on their smartphone, on their home computer, how can I remove it? I can't. So, server side, I'm sorry to say, but it's just a solution that works when you do it like that. The technologies it's built around is primarily Java, based on Java 8, using Java EE 7 as a basis for all the front-end parts, I mean the SOAP and REST APIs. And it's also used for the database part, so it's an abstraction layer that's present. It also means that the entire system is really, really small. A complete system built with all bells and whistles I've added to it is around 160K, so it's not really a huge thing in today's world. It's based on Java primarily because, well, I've done Java for many years. I really like that technology, and server-side Java has not really had that many really terrible security flaws. Most people who think Java is a terrible nightmare is usually looking at things on the front end, GUI, desktops, browsers. So for those, I hope you will trust me when I say that part is not something I've used. I'm just using the core backend part, which is actually quite good. Also because the JCE, this Java cryptography extension, is really a solid piece of technology, which also allows that you can replace the implementation. It's just an API. The entire system is stateless, meaning you can deploy it on several servers. It doesn't. They don't do any communication with each other. If you do, suddenly you will have a lot of memory keys in memory. You have to swap them over networks. No, stateless. Keep it simple. And finally, there's no third-party dependencies. Almost all the security problems you're seeing is always because someone have included some kind of dependencies from somewhere, and you end up with a system that has a lot of bloat in it because you just thought it was a cool little feature somewhere, you just want to use it. Yeah, there are good software out there, cool little features, but also potential threats. So only Java, nothing else. Standard Java, I should mention. No third-party dependencies. So the security features added. We have this fantastic algorithm called the PBKDF, and it's version 2 that's currently the most used. It's a way to take a passphrase, password, stretch it, and generate a symmetric key based on it. Using this, I'm allowed to go in and unlock the private key for a person, thereby suddenly granting access to everything internally. So that's what I'm using for people to log in. All keys are encrypted. Well, not the public key from the asymmetric key, that's not encrypted. That kind of would go against the purpose. And by default, the first time someone installs the system, I have an admin account for the administrative parts. There's no password set for it. Because one of the things I always remember reading about is, oh my god, the default password in this thing has not been updated, and a lot of people are misusing it. So how about we just change it around? The person who sets up the system sets the password. Thereby, I have no idea about it. Nobody else knows about it except that administrator, and he can pick, or she can pick any password preferred. Since it may be a system that can be used in environments where you may not trust things, for example, a journalist travels around a lot, goes to unsafe countries, and they have a lot of things on the phones. So if you have access to the system on your phone, and you have an account for your phone, just for that phone, and you have a second account at home in the office, and you suddenly lose your phone because, well, the custom services say, I just want to make sure it's okay. After that, do you know if you can trust it anymore? Nah. Invalidate the account. Basically, it means everything looks like it's working correctly, but the keys have just been destroyed. Data corruption checks. I don't know how many of you are as old as I am when it comes to IT, but I have been working on systems where you have something running somewhere for many years and it was never rebooted. So suddenly you don't know, is that server still something we can trust? Is the disk going to corrupt or crash on us when we reboot it? So yeah, I have experienced that, and that's going to turn into many hours of work. So I added a little sanitizing functionality into it, so you can just say everything which has not been touched by any user or someone accessing data within, say, 6 months, configurable of course, it's just going to be read in. We're going to make a check of the make a checksum check of it, and if everything is fine, cool. If not, we'll flag it, and then it's possible for the administrators to read a list out of flagged files to see, there's some parts which is corrupted. Either we hope you have backup so you can restore it from that, or you just have to live with the fact that this is encrypted and there's something wrong with the bytes, and I'm terribly sorry, but that data has been lost. Another thing is, when you're running in memory, you want to make sure that your runtime environment, that the data in the memory is only there as briefly as possible. The shorter the time, the better. So I'm trying to also actively destroy sensitive data. I mean, we're talking about the user's passphrases. And I also wanted to destroy the keys. Unfortunately, I don't know, is anybody here working for Oracle or from Oracle? Hi. Can you please talk to Sean Mullen and ask him to fix these 3 bugs? Because it's kind of annoying that that there's a wonderful feature in the OpenJDK saying destroy a key and it's not implemented.
Why don't we take that offline, please?
Yes, we can. I just wanted to mention it. So, the API, as I tried to mention, I tried to work on a versatile API. Communication using web technologies, SOAP, REST, kind of like a standard. It's XML based for the rest, mainly because for all the crypto handling, some of the objects can get a little bit more complex than just a simple listing of data. There's more things to it. Documentation, well, the entire system should hopefully be well enough documented so people can understand it, implement it, use it. All of it is written in Javadoc. And of course, there's a lot of functionality for administrating, configuring the system, creating or adding members to it, creating circles of trust, and adding, removing, changing trustees. It should be mentioned that the system administrator in the system has a special account, cannot participate in a circle of trust, mainly because, well, that could be construed as a security problem for many if you don't know if whoever is setting up the system is also adding a system administrator to all your circles of trust. So anyone who has access can create circles of trust, as many as they like, add as many trustees as they like, but not the system administrator. Since this is going to be hopefully used by companies, by organizations, private people, creating new members is only allowed by the system administrator, mainly because that could be some area where there's billing information or other things you want to control. Also, if you want to add a lot of people to it, you want to make sure that people don't just invite all the funny friends in. And I had one little request from a potential customer that's about signatures, so it's also possible to sign documents and verify the signatures of these. And one little curious thing regarding the data, that is also added something called a data type. A data type is an optional information. If you have a system you're building and you have distributed interfaces for it, you may not have the exact same information about how to interpret a blob of bytes coming back. So data types is just a way to say this blob of byte is supposed to be this object, and thereby you can interpret it. Blob of byte can of course also be files. It's anything. It's up to whoever uses it. So the quality of it. I have tried to make sure that the system is really, really well built. So close to 100% code coverage. The exact percentage is 99.6 if you want to know it. And yes, a lot of the setters and getters are tested in case there's a lot of programs around who frown about that. But once you start testing everything, they automatically is included. So it's not like they intentionally test it, but automatically also test it. All tests is done through the public API. I'm also having builds running constantly. Every time there's a commit, it's going to a Circle CI and Travis CI. And they're both running a build to make sure that the system is always in good shape. And there's a lot of static analysis running. I really like Synopsys Covariety. It's an extremely expensive system to use for non-open source projects, but for open source, it's for free. And it's good. Sonar Cloud, also a really good system, checks a lot of things, but doesn't get as deep as Covariety. And finally you have Codacy. Codacy is more, as I put it, more based on the styles of the code. So it doesn't go so deep into the security problems. Of course, we have manual reviews. We have a dude called Michael who was doing a lot of code review for me. And I even have a pen tester, Jennifer, sitting right in front of me. So, who is this actually for? Well, it is supposed to be for anybody who require central storage of data and would like to make sure it's safe. So privacy concerned individuals, organizations needing to share, companies needing to share data, anyone. So a couple of use cases just to show what it can be used for. Everybody here knows Dropbox. Dropbox has a plugin called CryptoBook, if I'm not mistaken, which allows that you, from a client perspective, can encrypt some data, put it into a Dropbox, centrally stored somewhere, but Dropbox itself is not encrypting anything. That also means that you, from Dropbox, can create a public link to a piece of data and someone can get it through the public API. But if you really want to trust your data, if it's something really sensitive, Dropbox is not really the best solution. So instead, you can use this. Everything is encrypted using user credentials, going down with the asymmetric and symmetric keys. And it's possible to create folder structures and put data into them. And here you can see data type can be a MIME type if you like, or don't. Up to you. So you can, if you like, you can just set up your own cloud system, put CWS into it and run things from there, then it's yours. Or you can set up a group sharing system. You can set up for companies, organizations, up to you. Everything is open source, no strings attached. The more interesting use case is this one here. When I started working on this was actually what I wanted to do. I had a couple of ideas for some mobile apps I wanted to build, and I needed a central storage of data. And it was just always a problem finding something that's encrypted. How can I store it? A lot of companies offer something like this, but it costs so much money. And you have to go and have custom built things. And no, I want to have something I can use like I want to. So, let's take an example. If you are often going to a doctor, in Denmark, where I'm from, they are storing a lot of information in a central place. Meaning you go to the doctor, you get a prescription, go down to a pharmacy, you give your information, and they pull out the information from the system. Unfortunately, it's not really encrypted. It's stored somewhere, and there's been a few little tiny hiccups with that. Germany, you kind of have the opposite thing. I go to one doctor, I get a prescription for something. I go to another doctor, I get a second prescription. I don't know if these two prescriptions, if there's going to be any kind of weird complications if I take both types of medicine. So it's really good if the doctors could somehow talk together. So we can build some kind of crypto medicine system where you come into a doctor, put your finger on top of some kind of little fingerprint reader, and the receptionist open up your profile, and it's then going into the system, extracting all the data, decrypted because you gave your fingerprint. Then the doctor can see it, update your information, save it all, and then it's closed, gone. Doctor cannot access it again. Then you go to a second doctor because you had a referral to a second doctor. Or you have to go to the pharmacy and pick it up. Pharmacy can't read your weird doctor notes. Okay, most of them actually use computer data to print it out, so it's easier. But in old days, it was like a guessing game. But many of these places, it's good if you can go in and you can, if you go to a second doctor, it's good if you can, they can somehow extract your profile. So if you go for an operation, it might be helpful if the doctors at the hospital can see that you might have some medical issues regarding heart problems, blood pressure, something like that. I have an entire family working in the medical sector in Denmark, so anyway, that was just an example of how it can be used. And I think all were mentioning, and we are the company I'm working with. I want to make integration. That's SysLab, and they actually want to build some kind of things with Plone just to see that there's actually real life usage of this system somewhere. Another thing, I already mentioned, journalist is a fourth estate. It's like we really have to take care of them. They travel around, they do a lot of digging, a lot of things, and they get into trouble some places because they are working with whistleblowers or sources that they shouldn't have access to. So we have to do something about these journalists, and a suggestion would be to work on a journalist app, whistleblower app, call it what you like. A way for a whistleblower to contact a person. Let's take an example. You have a janitor working at Trump Tower. The janitor suddenly finds a stack of pictures lying somewhere after they were sweeping around with Putin on them and Trump, doing things, let's just say, we should not know about. However, someone may want to know about it. So how can that person suddenly get that information out? You have Russia on one hand, you know that they how they treat former agents of their country, like Skripal, that was funny, not. You have America, who is the good guys, who of course never have done anything bad to people who have tried to show information. You have, of course, online systems like WikiLeaks, where you can also say, well, we want to push all our data there, but Julian Assange, he's stuck somewhere in an Ecuadorian embassy in London, and whoever visits him is filmed by about 10 different journalists at the same time. So we cannot really trust him either. So what can we do? So it was just build a journalist app for whistleblowers. You set up, as a journalist, a CWS instance somewhere. You add the whistleblower by an invitation. So the whistleblower doesn't give a lot of information. You just, here's some kind of contact information. You use that, set up an invitation, give it through a different channel to the journalist and the whistleblower. And the whistleblower can then, by him or herself, access the system and thereby you can start sharing data. And it's all encrypted, so hopefully it might be enough to hide your tracks, especially if you combine it with something like Tor. Suddenly you have a really hard set of security built up around your exchange of data. So that was one case. We can also take a more exotic use case like CryptoChat. I don't know if anybody here is familiar with Signal. Okay. That was a report a few months ago that Signal had a vulnerability, which was that all the keys, all the information is stored client-side. Meaning, if you have a group set up and you want to kick out a person, well, that person has a phone with the app, with the ID of the group you're in, you have the key, and you have everything. And that's actually a hole in the system, so it's possible via the API to get in and reattach yourself to that group. Not good. So, I started mentioning early on that one of the key features in CWS is the key management part, where I put everything server-side. If you combine client-side and server-side and have double encryption, if you're kicked out, and even though you still have access to the keys and everything client-side, if you're kicked out from a server also, you cannot access that data anymore. You don't have access to that key. You only have the one half, not the two halves, not both halves. Can't get back in. So it was just an example of trying to introduce CryptoChat. Cool. Unfortunately, Freema already exists, so I can recommend that. Another exotic use case, CryptoBook. We all heard about Cambridge Analytica and Facebook having a little, playing around with user data in ways that users really don't like. Unfortunately, this kind of got completely obsolete this morning when I read that Mark Zuckerberg, he has agreed to apply the EU GDPR rule set globally. So, good for Facebook. Let's see when it's going to be done and if they're going to do it properly. But if it's all true, good. So, okay, now getting into the more interesting thing. Trouble areas. I have to ask, is that Tamas here in? No, he's not. Okay. Well, when Beside Munich announced on Twitter that I was giving the talk, he wrote, and I wrote back. The areas of concern is, of course, when it comes to any computer system, it's patches, configuration, making sure you have the correct setup with firewalls, your network is encrypted using SSL. Gonna leave the runtime for a short moment. And the real danger for most of us, we have already seen a couple of talks about users and how much we can trust a user. This is actually the place where I think most hacks today that occur through a user. You can build up the most secure thing. I mean, a good example. During World War II, or before World War II, the French people were a little bit afraid of a country called Germany. They built a huge defense line called the Maginot Line. Huge. Lines of train tracks going in so they could transport ammunitions and troops, and they could move it all around. It was a huge thing. So what did the Germans do when they wanted to attack France? Well, who cares? We don't want to go through that. We just go around. Classic thing. Real danger is the users. You can build as many firewalls, as many things you can do, but it boils down to users. So we can patch our systems, we can make sure we have everything running perfectly fine with firewalls, with networks, completely secured. There is one area where I will say it's a little bit hard to secure it, and that's the runtime environment. The virtual machines running. And that's why we come back to this discussion of reflections of trusting trust. How deep down the rabbit hole do we have to go? If you want to build something high secure, and you want to use a public cloud, You don't know anything about the specs, how they're running. You don't know anything about the hardware they're running on. You cannot add your own hardware. You have to trust what's there. It boils down to this. You have to trust it. If you don't trust it, don't use a public cloud. Set up your own server somewhere. You can go to a hosting provider and say, okay, we're going to have our own servers installed here. Well, that's a huge rack. Hopefully they don't have a copy of the key for that rack. How deep down the rabbit hole do we have to go? For small organizations, they can't afford having something hosted in a hosting center. That costs a lot of money. You can maybe go to a hosting provider and say, I want to rent a server. You can do that. It costs 10, 50 euro a month. It's fine. Most organizations can afford that. But you have to put your trust somewhere. And for this system I built, I just had to say, okay, this is the point where I have to apply a trust. I trust that the administrators at Amazon, Google, whoever is running this system, that they do not screw up with the runtime environment. They don't go in and keep making memory dumps or whatever to read all the keys out, all the unencrypted information. That's a place where I had to put the trust here. So for Thomas, who unfortunately is not present, so I can't say it to him directly, this is the area where it is not possible to add a lot of trust. If you want to do it, you have to go into the part where I talked about earlier, where you have to use different JC implementations. They're here under HSMs, hardware cryptography. So, future plans, generally, support for more JC implementations. We want to have someone implementing the system. We also want to add something ourselves, me and 2 or 3 other people. Integrating it into other applications would be cool, but we don't have all those applications. Someone else hopefully has areas where they want to use it. And one of the other things we are considering for the next version is copy and moving. So you can copy move data between circles. Changing the keys using a read key feature. So if you say your data is kind of like, we want to change our keys frequently, you can do it. And a master key. Master key is in progress. I have not completed it yet, but it's also something that's going to be added. So it's possible to have master key plus a user key. So both have to work, otherwise forget about it. And any other features someone else may wish for. So, from SysLab, Alex, friend of mine, he wants to integrate it and also make sure we can provide some kind of commercial support if people want to use it and buy it. And basically just from you guys. I hope that you will help spread the word about the system. It's an open source, volunteer system. It's tried to build to protect data and improve security. It's not perfect, I'm sorry, but hopefully it will make sure data is a little bit more safe. Thank you.
Oh, any questions on this one? We got one little package left. You raised your hand first.
Thank you for the talk. I'm not getting what you're trying to put there.
Sorry?
I'm not getting what you're trying to put there. So your primary goal is you take a cloud sample like Google and you put the stuff up there, right?
Yeah, I mean the goal of the system was it's a back-end component you deploy and you can use as part of other applications, which basically just another layer in your stack.
Yeah. So
you come in with data.
That I got.
Okay, and
then
then
to deploy it into a public cloud, right?
You can. It's up to you as a customer, user.
There is nothing gained to put it in the public cloud, right? It's
Sorry?
equally good if I put it in the public cloud, I say I need to trust Google anyhow, put a base out in front of it and remove the stuff out.
I'm not sure I get your point here.
The data is also encrypted.
Yeah, it doesn't help if you run it in a public cloud with the key management on the server side.
Yeah. Do you trust Google's cloud management of the keys? Amazon's?
If you run the code with the key management in the cloud, you're trusting Google anyhow.
Yeah, but why should you?
Yeah, you said
This system here is not there if you trust Google. It's there if you don't trust Google.
Yeah, but your point was, if you're a small company, you put it into the cloud. Yeah?
You can put it into cloud if you like.
Yeah.
And you can add the security from Amazon, from Google, or from Oracle, or whoever. But they provide some kind of security features for you. But then again, do you know that when the Americans, Department of Justice or FBI, CIA, whoever, comes over and say, we want to see the data. Can you trust that Google, Amazon, Oracle, that they are not going to hand over the keys that they're using?
No, you can't, but
that's the point.
Where is your software running then?
So let me see if I can understand what you're asking.
I'm not getting
and
what
say
is
this a little bit
stuff is
louder
required.
because I don't know if everybody's hearing. So what you're saying is he's criticizing the cloud and saying that's why he's making this cryptographic web store. Then on the other hand, he's proposing putting it in the cloud.
Yeah.
Is that what you're saying?
Exactly, you got it correct.
Okay.
Yeah, okay. I see it. It's a bit of a... It is a problem. Some companies really, or organizations really want to use cloud for everything. It's like the huge new thing. Everybody has to put everything in the cloud. But you may have the problem you do not trust those clouds because the key management they are offering is not something that you like. This is just going to add one more layer of security to it. So if the way they manage their own keys doesn't really live up to the EU regulations, well, what do? This little system here is only there to add one more layer. It's not there to provide perfect security, it's just there to try to provide one more layer of security. Does that answer your question?
Partially, yeah.
Okay, I suggest we wrap up because we have a talk at 12:10 in the other room. It's not being recorded, so if you want to have time to catch on the other talk, that would be a good opportunity to go now. We have a couple minutes left. Thank you.
All right, thank you.